Algebra 2, this is lesson 3.5, operations with matrices. Matrices are a method of writing systems of equations without all the x's and y's and so on. A matrix will have brackets around it, and it will have some numbers in it, and they can be various sizes. We associate or name matrices with a capital letter and the size. So this could be named A with 2 by 3 as a subscript. This 2 by 3 is related to the size. Matrix sizes, matrix is for one, matrices is plural. Matrix sizes are given as rows by columns. And we call this one by. When you go to the lumber yard, you buy 2 by 4s, 2 by 6s. Well, matrices are named in the same way. We need to establish, because students always have some confusion, this is row 1, this would be row 2, this would be row 3, and so on. So rows go across. This would be column 1. This would be column 2. This would be column 3, and so forth. There is no limit to the size that a matrix can be for us to work with. In order to add and subtract, matrices, they must have the same dimensions. Or another way of saying that is they have to be the same size. If two matrices are not the same size and I ask you to add or subtract them, then instead of writing no solution, we use the word impossible with matrices instead of no solution. And there's one other word that we need to talk about. It's called a scalar. A scalar is just a number, which can be a fraction or whatever, but it's a number to be multiplied by a matrix. Okay, if you will look at number 1 in the lesson, first of all, you need to check it is a subtraction, and it says to be sure, or I'm telling you to be sure that they are the same size. And the answer is yes, they are the same size, because this matrix is 2 by 2, and the second matrix is 2 by 2. It's usually easiest to think of a matrix based on positions. So this is the first seat in the top left corner, and this is the first seat. So you would have 8 minus negative 4, which is 8 plus 4, which is 12. Then this one is 7 minus 3, which is 4. Then this one is negative 10 minus 2, which is a negative 12. And this one is negative 6 minus a negative 12, which is negative 6 plus 12, which is a 6. That should appear pretty easy because it is. Let's look at one like number 4. Number 4 combines a couple of things. Okay. This has scalar multiplication because this is saying multiply everything in the matrix by negative 2. So that would be negative 16, positive 2, 0, negative 10, negative 12, positive 12. And we want to add that to 4 times negative 1 is negative 4. 4 times 0 is 0. 4 times negative 1 is negative 4. 4 times 5 is 20. 4 times 10 is 40. 4 times 15 is 60. Now we are ready to add the matrices, but we have a problem. This matrices has 3 rows by 2 columns. This matrix has 2 rows by 3 columns. Because these dimensions are not the same, this is impossible. The next problem or so that I'm going to talk to you about is not in your composition book, but you need to write it in your composition book so that you know what we're talking about. They will often give you some matrices and then they will ask you to do something with them, like A minus B. These two matrices are the same size, so I can literally take 1 minus 7, which gives us a negative 6. And I can do 2 minus 8, which gives us a negative 6. And I can do 3 minus 9, which gives us a negative 6. Then I can do 4 minus 10, which gives us a negative 6. I can do 5 minus 11, which is negative 6. And I can do 6 minus 12, which is a negative 6. But you could also be asked to do B minus 2A. So that means we're going to have B, which is 7, 8, 9, 10, 11, 12. And I multiply the negative 2 times A so that I can add, because I would prefer to add. So negative 2 times 1 is negative 2. Negative 2 times 2 is negative 4. Negative 2 times 3 is negative 6. Negative 2 times 4 is negative 8. Negative 2 times 5 is negative 10. Negative 2 times 6 is negative 12. Now we're ready to add these to get our answer. 7 plus negative 2 is 5. 8 plus negative 4 is 4. 9 plus negative 6 is 3. 10 plus negative 8 is 2. 11 plus negative 10 is 1. 12 plus negative 12 is 0. So Don't make those difficult just because they give you letters for the matrices. Okay, on the second page of the notes, it has a chart and it asks you to analyze data. And if you look at the construction problem, they've worked the first example for you about ticket prices, but we need to look at the construction problem. It says, during each of the last 3 weeks, a road building crew has used 3 truckloads of gravel. The table at the right shows the amount of gravel in each load. Number 1 says, determine the average amount of gravel used in week 2. So if you look at week 2, you have 40 tons, and 32 tons. Well, when you're finding the average, that means to add those together, and then we have to divide by 3 because that's how many we have. So that would be 37.3 tons. Number 2 says, what was the total amount of the gravel delivered by load 2? Load 2, you're reading across the row, so you have 32 tons for week 1, plus 40 tons for week 2, plus 24 tons for week 3. So your answer is 96 tons. Number 3 says, which load delivered the most gravel per load? On this question, they're looking or wanting you to look at load 1, load 2, load 3. And if you add up load 1 across, it's 112 tons. If you add up load 2 across, you have 96 tons. If you add up load 3 going across, you have 80 tons. So the load that had the most gravel per load would be load 1. Then number 4 says, during which week was the average load the greatest? Now we're going to add up the weeks. So week 1 is 40 plus 32 plus 24, which is 96 tons. Week 2 is 40 plus 40 plus 32, which is 112 tons. Week 3 is 32 plus 24 plus 24, which is 80 tons. And it says which week was the largest. That would have to be week 2. You should be able to do practice 3.5 at this time.